Hi, I'm Yusuf Abdullahi and I work as a tutor at statisticassignmentexperts.com. I'm going to explain to you solution of an assignment based on the peer sample test. The question goes thus: four salesmen were given extensive sales training and then we want to test whether their sales performance improved using 0.05 level of significance and assume normally distributed populations and unknown standard deviation. So what we are going to do here is to use a paired sample test to see if there is difference between performance in sales before and after our training. So we can see that for salesperson A, the sales performance improved from 12 to 15, for B to 13 to 17, for C 10 to 14, and for D 11 to 12. But this is not enough justification that the sales training is actually effective. You have to subject it to a statistical test to determine that. So why paired sample test? We use paired sample test because we have two observations for each person. That is, it is a repeated measure for each of the sales person. That is, one was measured before and after training for the same person. So it means we have a paired sample, then we use a paired test. So assumption of normally distributed population is one of the assumption of paired test, and then unknown standard deviation make us to use the independent test. Then let's see how we utilize that. So the first thing is to state the hypothesis, the null and alternative hypothesis, and we have that mu d equals to 0. That's the null hypothesis, where our mu d is the difference, is the mean of the difference in sales before and after. I mean the difference here, 12 minus 15, 30 minus 17. Then we have find the average, that is our mu d. Then the second step is to check our assumptions. So we have that the observations are independent of each other. That is, all the observations they are not related. One does not depend on the other, which connotes that all the samples were random. Then the dependent variable is measured on an interval scale. So as we can see that the sales performance is measured on an interval scale. Then the differences are normally distributed in the population. As they say, we should assume normal distributed population. Then so we can say yes, the differences are normally distributed in the population because we have been told to assume it. Then step 3 is to specify the level of significance. So the level of significance I'm using here is 0. The level of significance is 0.05. And the next step is to calculate the test statistics. So the test statistics is for paired sample test is given s bar d minus 0 all over sd over square root of n, where our s bar d is the mean difference in observation and sd is the standard deviation of the difference and n is the number. This denominator sd over n is the standard error. So how do we come across about our x bar d and sd? So what we do is to create a new variable d, which will be the difference between sales performance before and after. So we have 12 minus 15 minus 3, 13 minus 17 minus 4, then up to the last sales person. Then we find the average. So if we add this and divide by 4, we have minus 3. Then finding the standard deviation, we have 1.414, and the number of observations we have is 4. We can now proceed to calculate our t. Our t statistics. So we see that our T, we have minus 3 minus 0. This is our x bar d, and then this is the standard deviation 1.414, and then this is the square root of n, which is 4. So calculating this give us minus 4.24. So minus 4.24 is our test statistics. Then the next step is to determine the critical value. First, to determine the critical value, we need two things. We need the degrees of freedom and the alpha level. So how do we calculate degree of freedom? Degree of freedom is n minus 1, where n is the number of observations. So we have 4 observations here, 4 observations here. Then our degree of freedom will be n minus 1, which is 4 minus 1, that's 3, right? Then 0.05 alpha level. So we can go here and check a t-test table, level of significance for a 1 t-test, level of significance for a 2 t-test. Since we are using a 2 t-test, we are concerned about here. So we can see that the n minus the degrees of freedom are here. So we can see that this is 3. Then if we trace up to 0.05, we see that we have 3.182 as our critical value. 3.182. So that's how we got this 3.182. Then step 6 is to make decision. So how do we make decision is we compare the tabulated value, the calculated value with the tabulated value. If calculated value is greater than tabulated value, we can ignore the sign. Then we say that we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. So from here we see that the calculated value in absolute time is 4.24, while the critical value is greater than the critical value of what? 3.182. This means we are going to reject the null hypothesis that the mean difference is 0. So I mean we are rejecting this, that the difference in mean is 0, and then accept this alternative that the mean difference is not equals to 0. So therefore it means there is significant difference in average sales performance before and after. So what you are saying in essence is that average sales performance before and after training are not the same. So we then conclude, since we reject our null hypothesis, that means that there is significant difference in average sales performance before and after training. So we can conclude that sales performance has improved as a result of the existing extensive training. So for any assistance with statistic assignment, you can email to support@statisticassignmentexperts.com. Thank you.